Yeah.
All,
So
all right. So why don't we go ahead and get started here? It's a little after, I'm in Central Time, so it's a little after noon for me. Welcome for our FME and Transportation today, September 20th, 2023. Let's go to the next slide and do a speaker introduction today. So today we have the famous, the one and only Dave Campanas, so from Safe Software. So known Dave, I think Dave, we've probably known each other from just trade shows for probably, I don't know, 20, how long have you worked at Safe, first of all?
18 years now.
I was gonna say 20 years. Okay, so 18 years. And you hail out of, where you live at?
Currently out of Penticton, British Columbia, which is about
Okay.
400 kilometers away from Vancouver.
Okay, very good. So today Dave's going to talk about demystifying network transformers. And as you see here on the slide, his favorite FME transformer is the topology builder, which is cool, which is a cool one. And Lee's favorite food is pickles, which is really interesting. I think that's the first pickles we've had on here. I had some pickles for lunch, so don't hate me for that. So I actually love pickles. So what gave you your condition aversion to pickles?
I just don't like vinegar.
Oh, interesting. So it's like I don't like ketchup, but I like pizza sauce. So
Ooh, well, that's very different. Yeah, that's the vinegar.
yep, very good. So with that, Dave, I think what we'll do is we'll go ahead and just kind of turn it over to you and let you do your thing. And you want to take questions while you're presenting, or you want to field those afterwards?
If you've got a question while I'm presenting, yeah, jump in.
Okay, so those in the audience, just kind of raise your hand, and we'll keep an eye on the participant board here, and we'll just call on you, and you can ask your question or type it in the chat too. We'll also monitor that. So with that, we'll take it away.
Okay, hi. Today I'm going to be talking about some network-specific transformers in FME. These are transformers that are basically dedicated to dealing with network type problems. Now we've got two types of network specific transformers. We have transformers that can work on all types of networks. And then we have transformers that are specifically for sort of like river branching type networks or non-cycle networks. So those we won't be talking about today. We're just going to stick, since it's a transportation forum, we're going to stick with the network transformers that can work on like road networks. And there we go. So the first one is quite simple. It's called the network topology calculator. And what it does is, if you send in a group of connected lines, like properly noted lines and everything, it will group them into groups of connected lines, or it will it will find the network for you. And what this is really useful for is not so much finding the network, because you know you got one, is finding groups of lines that are disconnected from the network. And this is good if you're sort of like validating road data and you're looking for breaks in your network, etc. It can also be useful for like if part of a larger process. So say you're looking for areas that are dependent on like an arterial road or a highway. That's their only way in and out, which is, you know, big thing to know these days with the forest fire season and everything. So if you just delete the highway and then run the network topology calculator, it will find those islands of you know, subdivisions and stuff that have no other way out. It's an easy way of doing that. So that's that one. So I'm not going to demo that one. It's quite simple.
hi Dave, I have a question.
Sure.
Can I? Yeah, so in that situation, what if network connectivity has some defect? Would you use the topology builder or something to identify those defects? For example, it is possible you might have a community, because of some of the defects, end up not even connecting with the main network. So how do we identify that type of scenario easily?
Yeah, that would do that as well. And by running through the network topology calculator, it will assign basically an ID to each separate network. So normally the first ID one would be the largest network, and so that's the one you're not too worried about. What you're interested in, the smaller networks, the little islands. And yeah, it will find an island. I wouldn't use that as your only test, because you might have multiple connectivity routes from that smaller area or that smaller community, and only one of them might be bad. So I would use it as part of a process, and say add something like, what's a good one for finding dangles? Topology builder and looking for endpoints is how I usually find dangles, like things that look like they're connected but aren't really. But yeah, it would be generally as a combination. This is a transformer used in combination with some other tests as a sort of helper. Yeah. Any other questions on this?
Thanks.
Okay. So now the shortest path finder. I like this transformer. It's fun. So basically, this finds the shortest path between 2 points. Based on like shortest path through a network based on 2 points. You can set up the cost of the segment by length or attributes, and you can have like forward cost attribute, reverse cost attribute, which is handy if you've got like one-way roads, etc. You can say you allow it to do U-turns. It can also you're from in 2 points, because a lot of the points you're not exactly smack on your network lines. Like if they're the center of a parcel or something, you can have it snap to the points, the network lines you're from 2 points. And the cool thing, and this is something I just found out not too long ago, is it actually can do the traveling salesman problems. So this one I'm going to demo quickly, and just going to switch to my screen. So here we have workspace. It's got the shortest path finder right at the end here. So it's doing a little preparation on the data first. But what we're going to do here is, in my youth, I used to work as a pizza delivery driver, driving around Vancouver, bringing people their pizzas. And I was pretty good at it, so I could usually figure out the shortest path. But it was hard on the newbies who really didn't know the area. So this would be a good thing for the newbies to help them find the shortest path, so they don't have to do all the thinking. So we have here base address, which is our restaurant. So that's going to be our start point and our end point for our route. So that's, we've set the address there. And I've just entered here a list of addresses in downtown Vancouver that we're going to do our deliveries to. So we got 4 deliveries here. And if I should, and so the workspace is going to do a little prep here. It grabs the address locations, and it brings up the parcel polygon network of the downtown Vancouver just to find out where those addresses are. So it gets the center points of those addresses, and it builds a line, and we'll show you what that looks like. So this is kind of a starting lineup. So you've got the restaurant, and then it just builds a line to the points, kind of a random order. You can see this is a terrible line. You wouldn't want to do this route. So it goes through that. We grab the street network, the list of streets here as well. We project everything into UTM because the original data is a lot long, and that's not really good for measurements. So we just pick something, anything that's in meters or feet. Just went straight to UTM. And then the shortest pathfinder. I'm just keeping it simple, 2D length. I'm not putting in any speed limits or anything. We've got from to, and network snapping is set to yes. So what I've done now is since I've got my points are from the center of the parcel polygons, they're not going to be on the road. So I'm just saying snap those points to the road. And then we turned on the optimization. And the optimization here is, I've just gone with the automatic. You can go advanced as well. And then this is if you want like fine control over how it optimizes the points and everything. But I'm figuring it's okay. I'm just going to go with the automatic, and we'll see what happens. And then output, we have a path, and we have a modified from to. So if I look at the output, we have the modified from to. So what is done here is it's reordered the points to make a more optimum from to. And you also see that it snapped the parcel centers to the road lines. And that gives you sort of the direct, and then also calculates the path from the road lines. So again, it's finding the shortest path between the from the restaurant to all your locations. And there you go. Pretty straightforward. Any questions on the shortest path finder?
I'm not seeing any in the chat. I'm not hearing any.
Okay, cool. These workspaces, by the demo workspaces, I've made available to both, so we can share those out. And the data is actually from the Vancouver Open Data Set if you want to play with it yourself. Okay, so the next demo. No, the next transformer is a network cost calculator. Now this is, it's a little bit like the shortest path finder, but it's rather going from point to point. What you're looking here is the cost of traveling from any point along your road network. So it's good at setting up like what do they call them, ISO lines or isochrones, where you can calculate your travel time, etc. Away from a single point. Again, you can set and it's the cost of the shortest path. So each point along the line, it calculates the shortest path to that. Now the segment cost again can be by length per attributes. And now the cost itself is going to be stored two ways. And it depends. I mean, if you have 2D data and it's easier for you to access an elevation, you can store the cost as elevations. Or if you want, you can store them as measures. If you're going into a format that's happy with measures, and measures are easy to work with. And again, you can snap your points to the network lines. So let's have a look at that demo. So in this case, what I want to do is I have the street network and I have the fire halls here. And what I want to do is to divide all the streets in Vancouver as to what is the closest fire hall to them based on travel time. So it basically creates kind of like a fancier Voronoi diagram between all the fire halls, but this one's based on actual travel time, how long it's going to take to get there. So everybody knows which fire hall, or what, if the call comes in, you know which fire truck to send out. So again, there's a little bit of prep on the data going on the street data, reproject to meters. We're going to break the data into segments. So we're going to go on 2-point segments. So for each of these segments, we're going to calculate which fire hall is closest. So we chop that up. Another thing we want to do is we're going to do a little bit of aggregating of these geometries, but we want to keep the road ID, the original road ID on these features, even once we aggregate them. So we can't store these IDs at the feature type level. What we're going to do is we're going to start at the geometry level. So each of the segments within the geometry, we're going to store the ID as a trait on there. So we use the geometry property setter. That's just a way of stuffing attributes down the geometry bit, so they're retained when you do things like aggregation or deaggregation or path joining, etc. We have this attribute value mapper where I'm just going to take the type of road that we have coming in, and I'm going to map it to a speed. You notice that a closed road has I've just set the speed as 0.001. The reason I didn't set it to 0 is we're going to be dividing by this number later, and I just wanted to avoid the divide by 0, but just make it a very low number for the close, which should ensure that the shortest path is not going to go down any closed roads. So we got that sort of set up. We calculate the length of each segment, and we're going to multiply the length, or divide the length by the speed to get sort of meters per second, so we can best calculate which is the closest. It's just a bit of math there. We're going to take now the network cost calculator, and this is something I'm not crazy about, and I'm going to see if we can get this changed. It does a single point. So it does a single point for the network. But we've got 20 fire halls here. So right now the kind of workaround is we have to create 20 copies of the road network to do our tests with. And so that's what I'm doing here is I'm merging a copy of the entire road network onto that fire hall number and as an aggregate of lines. And next thing I'm going to do, I'm going to break up the aggregate. So if you see that we've got 56,000 roads coming in, we've got 20 aggregates coming out, one for each fire hall, and then we end up with 1.2 or 1.1 million lines out of that from those 56,000 original lines. So we've got a copy of the road network for each point. This is something I would like to see optimized, and maybe, you know, a way that we can do a sort of a multi-point calculation. And I'll send that to developers and say, hey, that would be kind of nicer. So now the network cost calculator is set up, 2 attributes, transit seconds in both directions. We're going to output the optimal cost as measure values. And we're going to snap the source points to within 100 meters. And we're grouping here by the fire hall name. So we've got all the streets with their each copy for its own fire hall, and we're going to do these in groups. So we're doing this calculation in groups. So what we're going to get out of this is, as we see here, about 1 million lines. So each of these lines has, as a measure on it, the distance, you know, the time distance, the cost distance from the fire hall. What we're going to do then is we're going to aggregate, or sorry, we're going to extract the measures from the 2 measures. So for each point, we'll know the from time, or for each segment, we'll know the from time and the to time. We're going to extract the road ID. So we have that, and then we're going to aggregate all of these. Each of the segments is going to be aggregated by the segment number with the cost times put into a list. So on each segment, we're going to have a list of the from to cost times for each fire hall on each segment. Then we're going to take that list and we're going to sort it. So we're looking for the shortest time, or the smallest cost time for each point. First we'll look at the first point, and then we'll look at the second point on that segment. Now, for most of the roads, the cost time on the lowest cost fire hall is going to be the same for both points, the to and the from points. But for some roads at the periphery of the zones there, we're going to have a lowest cost for one fire hall on one side of the road and lowest cost for another fire hall on the other side of that road segment. And so we're going to test, and we're going to look for differing names on either side, or different fire halls on either side. And if we do, we're basically going to take the value time is basically less than or equal to 1. And so we're just going to kind of pick the smallest side here. And I see an error in my logic, but we'll work that out afterwards. And then finally, we've done a bit of, we've messed up these segments a bit. We've got all these lists and stuff on them. So what I want to do is just chop everything off here. And we're going to use an attribute keeper to keep just the things that are interesting, which is the road ID and the fire hall name. So go ahead.
No, I was on vacation.
This whole week?
Yeah.
Cool.
Worries. So we've got this sort of information. We've mussed up all our road segments. So I use a feature merger basically at the end here to take a fresh copy of all the road segments, merge the fire hall information onto it, and then output the merged data. And if we look at what that looks like, we see here our fire halls, and then we see, I've got it split up. We see the other road lines tie, and you can see the different, by the different colors, the sort of divisions between the road sections there. And those are basically the fire halls. And that's basically it for the demo. That's in the information you get out of it. So resources, I'll make these workspaces available. The second one I've got to tweak a bit. The sample data used here is basically Vancouver open data. I grabbed the public streets, the property parcels, and the fire hall, all available as GeoJSON files. And that's it. So I hope that was useful. Any questions?
Hi, Dave.
Yeah.
Yeah, was wondering that you mentioned about that you have to kind of do Cartesian drawing with 22 file holes with network, resulting in over 1 million kind of 22 or 20 copies of root network. In that case, can that be handled through a looping algorithm, essentially one loop with the other one network to resolve this issue rather than creating so much data in the memory for processing?
You could. It's just that I really, as a rule, I really like to avoid looping within a workspace. Yeah, I'm not sure the benefit would be there. The caching, you could, let's see, the way this works, a feature merger, the aggregator. I mean, if you sorted this by group, and it should probably come out of this sorted by group, you can set up the network cost calculator. It's already using group processing by name. You could set this to when group changes. If you know that all of your lines are already grouped as in order, you could set it this way, and then your memory usage goes along a lot down because it doesn't have to cache everything. So it'll clear the cache whenever a new group comes through. I would say that might be the optimum way of doing things. Just making sure your order is right. In FME, like I said, looping is possible. It's generally not recommended because we have techniques that allow you to sort of unroll your loops, like cloners or these feature mergers that create multiple groups of data, et cetera. So we're kind of unrolling the loop before running it through. So we're making the process very linear. And then we do a lot of memory management to sort of make that work. By setting things up by order and having some of these settings on the feature merger network cost calculator where you can say switch up my groups whenever I occur the next one, and then you're not caching everything. I think that might be a more optimum solution to go.
Mm-hmm. So in this particular example, I might have missed what is the objective function, or what is the targeted time from each file hole that we need to reach? It's like
I wasn't going for a targeted time. What I was going for was, I guess, the best fire hall to go to. So if we look at the results, let me just turn everything on. Okay, that we've essentially, each street now knows its optimum fire hall.
Oh, okay.
So we don't have a target time because, I mean, we may get areas that are quite a distance between all three. But we can find, we know the best fire hall to go to first, assuming it's got all the trucks, etc. So yeah, it's not so much a target as in optimization.
Okay.
We could do targets. I mean, this is the sort of thing where you could use the same network cost calculator to, set a boundary around a target, and that'd be a bit simpler math, where you just look at your measures and go, let's keep all the measures within my target time, right? And then
I think for the real world scenario would be they're trying to position where to place file. Right,
okay.
and they need to have service time, typically within, let's say, 5 minutes or 10 minutes, or 5 minutes, hopefully, right? So they do have the object, function constraints to guide this effort. So I'm thinking how in that scenario so we can introduce that constraints and to see, oops, we need to add another fire hall in this location in order to meet that minimum requirement.
Ah, fair enough. Yeah, yeah, you could. So you're looking. Then you would build the isochrones around it, the fire halls, and look for the gaps. Yeah, yeah, that's possible. It would be a simpler workspace. I could throw that together too if you guys wanted a demo of that. But yeah, it would be a simpler workspace. I figured I'd chew off something a little bit more complex. But that's definitely doable.
Okay, good to hear.
Yeah. There's actually something similar. We already have on the FME community. There's I did about 10 years ago, so it may not be perfectly up to date, but it basically it gives you isochrones around a fire hall. So then you could pick your limit, right, and have that set. So
Okay. So I have another question.
sure.
So in transportation planning in particular, oftentimes they have origin destination matrix, identifying major traffic generation centers, and then they try to predict, or looking at the movements of people from one place to another. Is this something OD matrix, something that this can be positioned, using FME to address that?
Possibly that would be a shortest pathfinder then. But you'd be looking at different. You'd need to have something like a sort of congestion a matrix, or a matrix of how long it takes to go down each segment. That would change over the time of day.
Okay.
And then you use the iterative shortest pathfinders based on the changing, like for each set of values. If I'm getting your meaning correctly.
Okay, thanks.
But yeah, as you can see, and I guess I want to just stress a bit, is these transformers do a calculation for you. But they're generally, I mean, it's not it's a part of a process. In that we've got helper transformers before to prepare the data, and then we've got more helper transformers afterwards to interpret the results of the of what the transformer gives you. And this is the shortest pathfinder, not so much. It pretty much sticks out the shortest path. But again, there's some data preparation ahead of time. So yeah, these are kind of a part of a process rather than say a standalone tool like you'd say find an ArcGIS, etc. So yeah, I guess that's it.
All right. Do we have other questions? I just have a more for my knowledge. How long has the shortest pathfinder and the network cost calculator been out?
Has
it been in in FME for a while? Or are they fairly recent?
I think probably about 10 years.
Okay.
That said, the capabilities have grown. To be honest with you, I hadn't used the shortest pathfinder for a few years, and the fact that it can do the optimization, that is fairly new. I can't date back when exactly we added it, but it was a bit of a pleasant surprise for me. And yeah, but it's pretty much be fairly recent because a few years ago it wasn't there, or I didn't know about it. So
it's always amazing when even for you, these little enhancements sneak up on you, don't they?
Yeah, actually it's worse for me because you get old and I've been using FME since 1997. And the pathways in your brain get engraved on how to do things, when it's early. So there may be optimizations that I haven't run into and I don't know exist, or I just haven't noticed on the interface. And yeah, it's not till somebody points them out. I actually try to take seriously, I actually try to take a training course every few years, or to sit in on one, just to see what cool stuff has been added in since the last time I take it, because otherwise it's just things you run into, and with 400 odd transformers, you can't run into them all, right? So all you FME newbies, you've actually got an advantage on some of us old guys.
There you go.
Yeah.
So do we have any other questions or comments, or just even an off-topic FME question? Anyone in the audience here?
Well, I do have a few more questions.
Okay.
Sure.
And Eric, I know you, when you were with our DOT, snow plowing was a major winter operation, right?
Mm.
And I was wondering, snow plowing also has its routing issue, which pass, how the passing sequence going will minimize the roundabout, repeating the same pass, what have you. So Dave, do you see something that can be accomplished through FME like that?
I would say tentatively yes. Like I said, you can set up these shortest path parameters, so you could, set up all your class one. I'm assuming you divide this in class 1, 2, 3 like they do here. I'm on a 3. My road never gets plowed. But yeah, so you could set up all your primary routes first, and the closest distance between those. Possibly even taking into account that, well, you got to go down this road anyway, and even though it's a secondary route, you might as well drop the blade, right? Because you're going to have to add time, etc. So yeah, you could set up those sorts of calculations into your process.
I was even thinking on that, even with stockpiling of materials, right? Because a lot of times on the plow side of things, they'll leave from home base, go do their thing, and come back to home base because it's an accounting mechanism, right? That's where that truck's assigned to. That's where its cost center is. But sometimes it could be more efficient, depending on where supplies are at, right? Where you can refill and stockpile. So I'm assuming what you showed here today, if you want to do some type of optimization of that, you could have stockpiles, have quantities, places, and then be able to look at how they could run through a network.
Right. So in the winter operation, the sorting operation is not contiguous because you are limited by the salt you have in the bucket, so to speak. And so the other issue is like sweeping, I guess, has less limitation. While they scoop up the dirt from the pavement and routing, covering certain area, that would be similar scenario. I'm thinking about in transportation, typical DOT operations per se.
Yeah, I really found this fascinating, just looking at anyone that has a network, like a road network, and has vehicles on it, should do some type of optimization just to see if what we're doing as humans is as optimized as it could be, right? At least give some check to your sanity of and of course pitch that, right? Probably people wouldn't be happy if you wanted to change things around or propose, but it's always good to know whether you're being efficient or not. And I think the tool like this really helps validate the work that all the good work that everyone's doing.
Mm-hmm.
Anyone on the call here have any questions, comments? Doesn't like pickles?
Well, if that's the case, I have one other question. It's kind of not directly related to network optimization. Since we are mostly transportation people here, and we do linear referencing system. So in a linear referencing system domain, we call our LRS being network as well. And it is really designed for different purposes to my mind, because that type of network is really used as framework to associate events or attributes or assets to network. And so in that particular kind of subdomain of network, through Dave, from your knowledge of LRS and network, and do you see some of this transformers can be used in the LRS network maintenance as well?
I'm not sure. Maybe the network topology calculator might be sort of useful. The two ones I showed you here are. I mean, you could use the network cost to, if you wanted I guess, length-based measures. I mean, LRS is usually length. All the measures are length-based, and we have simpler tools to do that. Network cost calculator is really good for creating, I guess, non-length-based or length adjusted measures. So this kind of brings up a point about FME, and it is one area where we're a bit lacking in it, and I've asked for this, and hopefully we'll see it down the road. Is it would be really nice to have a way of doing measure math on some of this stuff. Like we have the expression evaluator, the raster expression evaluator. Nice to have a measure expression evaluator, so you could do a mathematical operation on all your measures without pulling them out through Python like you kind of have to now. But yeah, I would say that the network cost calculator, if for some reason you're doing sort of like non-length based measures or length adjusted, like I said, in this case, I'm adjusting the length by the speed limit, right, to give you a cost that's based on, or if you had a congestion. I mean, the best would be if you had congestion values, right? Because that gives you the true speed. Then you could do that cool Google Maps thing where it finds a faster route for you and reroutes you in mid-flight, right? So.
Thanks. We found that network topology builder is really useful in identifying LRS network defects, those minor gaps and kinks, what have you, oftentimes. And but in my LRS practice so far, we haven't been able to leverage any of the other more fancier or the type of optimization transformers that you represented. But we certainly we try to see if we can find some usage in
it is kind of a low sort of it's kind of a good geometry checker. I mean, the weirdest thing I've used the network topology builder for is someone gave me a OBJ file full of buildings to go into CityGML, and it was a single mesh with like multiple buildings in it, and I had to separate out each of these into a single building. And it was, the way I ended up doing was just breaking the mesh into triangles and using the network topology builder on the triangles to find all the triangles that connected with each other. So each network was a separate building, and that was the easiest way to separate them. So it's not just road networks; it's absolutely any type of network.
Thanks.
All right. Is there anything else here? If not, we'll wrap this up. Thanks, Dave, again for presenting. You're always a sport to come in and support the FME community. Really appreciate that. And then we'll be making the workspaces available, correct, to the people on the call? We'll put a note out and make those available. Our next presentation is scheduled right now for November 15th. So keep an eye on LinkedIn for what that topic will be. And it'll be at the same, I think the same time. And I think it's the third Wednesday of the month, of every other month. So we'll just keep an eye on LinkedIn. We'll get that out. And we're also always looking for presenters and presentation suggestions. So if you have any of those, please email Bo or myself, send us a message on LinkedIn. That works too. It's not that hard to do. I mean, so I encourage any type of presentation suggestions, or if you're willing to kind of show or talk about the cool things you're doing. So, and with that, I think we're good. I appreciate everybody being here today. Thank you.